Testing microphone, testing microphone. Testing microphone, microphone. Stree. We're doing a stree. I'm just changing the time output. Dude, it's so sad how much of a toll streaming takes on this laptop. It's like faster when I'm just not plugged in at a coffee shop. Like these numbers are all better. But I'm plugged in, but I happen to be streaming and it's not better. I don't know. Am I still wanting to move to Linux? No, I don't want to move to Linux because it's a terrible operating system usability-wise. I would move to it if it were a good operating system usability-wise, but I can't. And it's not because of lack of specific tools, right? It's not, you can't add one or two tools to Linux and fix it. The whole thing is broken. Now that said, Windows is becoming more and more broken over time, so maybe I'll end up escaping to Linux anyway at some point. But it's nutty. It's just such a shitbag usability wise. I can't deal with it. And like no, and the it's like the philosophy, the development philosophy under which it's made involves making everything somebody else's problem, and that's why problems don't get solved. The only thing that happens is the number of lines of source code goes up every year. It never actually gets better. What was the end result? Looking good? Yeah, we had good success last night. The stream's still up. I have not deleted it, so you could skip to the end if you want to know. I mean, I probably would do an operating system at some point, but not anytime soon. Again, like just too much happening. Too much happening. Also, I need a mouse. You're studying formal languages at university. Unless you are especially interested in formal languages for some reason, I recommend not wasting your time. Honestly. Can you explain the difference between ULP and the machine epsilon? If one ULP is the smallest difference between two floating point numbers, wouldn't the difference between one and the next float also be ULP? Okay, so floating point numbers. I don't know what you mean by machine epsilon. You're going to have to clarify that term. But like a reason a ULP is called that, it's the last digit of a floating point number, right? And the magnitude of that digit is relative to the magnitude of the floating point number, right? That's the whole point. So I don't know. I don't know what the question is. But I don't really encounter the term machine epsilon very much, so I don't know what that means. Maybe I would know what that means if I did a lot of numeric programming. It has to be so difficult to enable stepping, or it could have been done easier. What? What you... Like you didn't realize it was so hard to build a PDB file? Well, all these formats are more complicated than they need to be. What we've been doing the past few days is working on 2 formats simultaneously. All right, and so that's annoying. And dwarf is especially heinous. It's just stupidly complicated for what it actually does in reality. So I don't know. I mean, I don't understand what the question is that you're asking apart from that, though. I'm going to wait a couple more minutes, and then we'll do a spiel about what I'm going to try to do today. How do I like Chattanooga versus Nashville? Chattanooga is better. Nashville is just not really a nice place in a lot of ways. Like, it's not designed, like all the neighborhoods in Nashville are not, or the ones that I saw, are not really designed to be places that are nice to inhabit. They're just like, oh, we built this thing and there's some fucking buildings here and here's some shops and whatever. Even the supposedly nice, so there's this like Gulch neighborhood downtown that's supposed to be nice, and it's like terrible, right? Like, just bad design everywhere. Except for a little bit of the stuff like right downtown where everybody gets drunk, but that's not a neighborhood I would want to hang out in. So I don't know. What you don't understand is how ULP X can be different depending on X if it's the difference between the 2 smallest floating point numbers. It isn't. ULP, I just told you, it literally means unit in the last place. It literally means the last digit of a floating point number. It is a relative measure. It is not the difference between the two smallest floating point numbers, all right? That is simply not what it is. So if you had that impression, you are not correct. You're self-taught and feel like you're bad at knowing how to optimize your code performance. Any tips? Try to optimize things and measure. That's how I did it. And also look at examples of other people optimizing, but they have to be good examples, right? They can't be like, I'm doing some crappy web program that's 3 orders of magnitude too slow, and I took out a thing that does an RPC to compare strings, and now it's only 2.5 orders of magnitude too slow. Like, and I feel great about myself. Like, those are bad examples. You need good examples of people doing fast code. Am I looking for a place to move? Yeah. Do I practice any type of physical exercise? I used to do a lot of dance, but these days, not a lot of that is happening. Smallest difference between two floating point numbers? No. Look, thinking about the ULP as the difference between anything is just going to confuse you. It's not the difference between anything. ULP literally means the least significant bit of the mantissa. What magnitude does that represent? That is exactly what it means. If you keep trying to confuse yourself with other things, then no wonder you're confused. Don't think about ULP as the difference between anything. Not even consecutive floating point numbers, because two consecutive floating point numbers could have an exponent increase between them, all right? And that makes it x, that puts a bump in the function. That is not what ULP means. Just look, if you don't just go look at the format of IEEE floating point, IEEE 754, right? Look at the mantissa, the rightmost bit of the mantissa, that is the ULP. All right? You get it? That's all it is. How does Knoxville compare? It kind of sucks. I don't know. Parts of Knoxville are nice, and parts of it are terrible. It's very bipolar. You can see Chattanooga being very beautiful, but it also seems pretty small. It is pretty small, but I'd still rather have a small place that I like than a big place that doesn't really care about me, you know? All right, any on-topic computer questions before we kick into the mainstream? The mainstream. How does the type system work? That's an off-topic question. We have videos about that. Back-end questions, please. Back-end questions. Can we compile the game in Linux? No, we're not maintaining all the libraries for Linux. It's just it's too hard. We'll probably make it run in the end, but to maintain it during development is just a giant pain in the ass, and it's not worth it. All right, nobody has on-topic questions. I should just stop streaming. It's a disaster. It's a disaster. Do we plan to write our own linker? We don't want to have a linker. The idea of having a linker as a necessary part of your tool chain is kind of dumb, especially considering the way linkers work. We, in principle, don't need a linker at all if you don't try to link in any C libraries or libraries written in any other language. Unfortunately, most people are going to want to do that for the near future, right? Now, if you don't do that, we still do need a linker for the short term, but for example, on Windows, it's pretty easy for us to get around that by writing a PE file instead of an object file. I just haven't actually done that, but we could do it, right? But even for the game, we're linking like just tons and tons of stuff, right? That said, maybe we could link these as DLLs and just not link against the .libs and then just dynamically load them at runtime. I'm a little bit loath to dive into giant weird process complications like that, though. So I don't know what to do. It's just that linkers are a disaster. They're stupid. And they're most of the engineering effort these days, this is why linkers are so bad, most of the engineering effort goes into reversing or attempting to compensate for the terrible design decisions that are made in C++. That is literally it. Almost 100% of linker effort goes into that. That's why they suck for anything else. If you don't have a linker, then maybe it's harder to make incremental compilation. You don't need incremental compilation if you compile a full build in 1 second or less. In fact, it's better not to have incremental compilation because incremental compilation just creates bugs and uncertainty. So all these people blabbing about how cool their incremental compilation are just doing the C++ thing over again, but years behind, in my opinion. I'm just not very impressed by any of that. Does the compiler backend cache any metaprogramming results? No. The plan is just to be fast, yes. Is C generation supported still? No, but you can make that on your own if you want. Will you ever make an informative video on how to Lex parse type of language? Yeah, I did that with Casey. It's a 5-hour-long video about parsing. It's on YouTube. It is on YouTube. Do I tend to resurrect SOA before public release? No. Probably not. It just doesn't belong as a built-in compiler feature. All right. Questions are making me grumpy, so I don't know. Maybe I shouldn't have streamed today. We'll see what happens. Maybe I should have taken the day off and gone to the beach. Oh, wait, there's no beach here. Well, there's no beach here. There's no beach here. Ignore chat for an hour. Maybe. I mean, so the thing is, let me just talk through what I'm going to work on. And this is a little bit less structured than what I've been doing the past few days because I'm less sure about it. So this is going to be a little more free form. You know, like yesterday I started the stream and I was like, here's this very bad performance thing. That's our mission. And now our mission is going to be more like restructuring something. So let me talk about that. So yesterday, one of the performance issues that we resolved was that we were making a big array of like every bytecode instruction outputted by the backend at all, right? Actually, on Windows, we were essentially making two big arrays like that. One of them was broken into these subprogram chunks, but then each subprogram has an entry for every bytecode instruction, right? But then there was this other global one, right? And then Dwarf was only using the global one. So on Dwarf, we didn't optimize that out, but we broke it in and used the subprogram version. So now at least we have both backends working the same way. And so now instead of two copies of all this data that we would like to not have, we have one copy. And so the next step is to not even have one copy, is to drop down to not exactly 0 copies, but something that's more lightweight, right? So let me just start talking about why I don't like this. And actually, let me go off on a little bit of a discourse even before that, which is, you know, like I said in yesterday's stream, I didn't do a lot of code reviews while this code was being developed, right? Because again, I felt like I didn't have time. I had too many things to do, and always too many things to do, right? And I'm not sure if that was the right strategy or the wrong strategy. It was mostly fine because we got code that works and stuff. It's just that, you know, there are things to improve about it, but these things don't seem to take that much time to improve. Like we did a major thing last night, right? So all in all, maybe it was even a successful strategy to do that as long as you follow up and rewrite things. But, okay, the reason I wanted to rewrite this thing yesterday was, you know, it was very objectively a performance sinkhole that was not good, right? Today, there's more like things that probably make performance pretty bad, but in a more ambient way because they're spread around the program, right? They're not like all gathered into one tight loop like yesterday, right? That was the ideal case for optimization because you see something that's really slow and you're like, wow, we shouldn't be doing that at all. And then you make your program not do it at all and you get all that time back, right? So this is a little bit more of a fuzzy thing, but it's one of these things where, you know, over the past couple of years, while I was working on front end stuff or whatever, things would get added to support debugging and they would make me really unhappy, but I couldn't say much about it because I didn't really know how the debugging code worked. I didn't look at the back end, right? I was too busy. I was doing front end stuff. So I was just vaguely unhappy and grumpy about certain things being added. And those are the things that now I get to confront. And the nice thing is, hopefully I get to make myself more happy about this. So let me talk about this. In both the code view and the Dwarf backends, there's a loop that does something like this. It's time to output the machine code, right? You get a lambda as an input, and that lambda has an array of bytecode instructions, which are our internal representation. And this used to, before we added debugging output, be a